Hello guys, welcome to our channel Last Minute Electrical. In my previous class on graph theory, I have discussed what is complete graph, what is incomplete graph, what is connected, unconnected graph, what is mean by node and what is mean by branch. This thing I have cleared in my previous lecture, but today in this lecture I am going to cover subgraph, tree, co-tree, twig, link and incidence matrix. These three topics I will cover in this lecture. Out of these 4 and 5 topics I will cover in my next lecture. Okay, so let's start. Okay, now I will start. What is subgraph? What is subgraph? A graph GS is said to be subgraph of any graph if all the nodes that are present in GS and all the branch that are present in GS is also present in the main graph G, then we will call GS is the subgraph of G. Now let us take an example. See, this is a graph, G. Suppose this is a graph G. Okay. Now see, I have drawn two graphs, you can see here. Now check this graph. This graph have A, B, C, D nodes and 1, 2, 3, 4, 6, these 5 branch. Now if you check, you can see that all these 5 branch, that is 1, 2, 3, 4, 6 are also present in that main graph. This main graph contain 1, 2, 3, 4 and 6 branch also. This, if you see, check this graph, it has A, B, C, D nodes. This graph also has A, B, C, D nodes. Okay. So what is extra in this graph? This 5 branch is extra in this graph. Okay. So now I can call this graph is the subgraph of this main graph. Okay. Now if I represent this graph as G and if I represent this subgraph as GS, then I call this GS as a subgraph of this main graph G. Okay. Similarly, if you take this example, see here 3 nodes are present A, B, C. These A, B, C nodes are also present in this main graph G. A, B, C is also present. Moreover, 1, 2 branch, these 2 branch are present in this graph. Also this 1, 2 branch are also present in that main graph. What is extra present in this main graph? This 5, 3, 4 branches and also these D nodes. So what we can call? We can call this graph is the subgraph of this main graph. Okay. If G is my main graph, then this is your GS, which is known as subgraph. Okay. So GS is your, this is another subgraph. Okay. This is one subgraph, this is another subgraph of this main graph. Okay. Okay. So now I will discuss what is tree and what is co-tree. Okay. So what is tree? Tree is a subgraph of a given graph. Now just take this graph as a given graph or reference graph, okay, or main graph. Now what is tree? Tree is a subgraph of this main graph. Tree is a subgraph of this main graph which contain all the nodes of this main graph and which do not contain any loop. Okay. So now if I draw a tree, you can see this is the tree of this main graph. Why this is the tree? First condition, what I told you, it will contain all the nodes of the main graph. So main graph has, see, 4 nodes A, B, C, D, and this graph also has 4 nodes, this A, B, C, D, same nodes. And now if you check, also you can see this graph do not contain any loop. Okay. So this graph is a subgraph of this graph. So this subgraph is known as tree. So tree is a subgraph of main graph which contain all the nodes of the main graph, but tree do not contain any loop. Okay. Okay. So now if I draw the rest of the graph, what is the rest of the graph? See, this is the rest of the graph. This branch is not present. This is the rest of the graph. I am drawing it in a dotted line. this branch is not present in that graph. So, this is a branch and this branch is not present. Okay. Okay. So, this is the same direction I am taking 6, this is 1 and this is 4, okay, and this is 5, 2, 3. Okay. So, the dotted portion, this solid portion, solid line are the tree that I have already told. So, what is the rest of this main graph? Rest of the main graph is 4, 1 and 6. This 4, 1 and 6 is known as complementary tree or co-tree. Okay. So, the dotted portion is complementary tree and the solid line is a tree. Okay. So, for your convenience, if I take another example, now if I draw a tree from the main graph, another example I am taking. Now, see if this can also be a tree. See, first I am drawing all the nodes. Why? Because you already know tree contain all the nodes, but it do not contain any loop. So, first I am taking all the nodes. Okay. Now, see, same direction I am taking as main graph. This is 2, this is 3, this is 4, this is A, this is a D, C, B. So, it can be a tree. Why? Because it do not contain any loop, but it contain all the nodes A, B, C, D that are present in that main graph. So, this is also a tree. So, what will be co-tree? The rest of the graph will be co-tree definitely. So, this will be, this dotted line will be the co-tree. This is 6 branch and this is 1 branch. Okay. So, this 1 and 6 constitute the co-tree. Oh sorry, this is also, I forget to draw, this is also the part of co-tree. So, 1, 5, 6 constitute the complementary tree, 2, 3 and 4 constitute the tree. Okay. So, this is tree, this solid portion is tree and the rest of the portion of this main graph is known as co-tree. Okay. So, now I will discuss what is twig and what is link. Okay. So, what I told you, this solid line is the tree, okay, that is 4, 3, 2 is a tree and 1, 6 and 5 constitute co-tree. Okay. Now, what is twig? Twig is the branch of tree. So, branch of tree is known as twig and branch of this co-tree is known as link. That means, here 4, 5 and 2 are twig. Okay. So, that is the branch of tree. Okay. And 1, 6 and 5, 1, 6 and 5 branch are links, are link. Okay. That is the branch of co-tree or complementary tree. Okay. Now, one thing you always remember, that is in a tree the number of twigs is equal to always n minus 1. Okay. In a tree the number of twig T is equal to n minus 1, where n is the number of nodes that is present in that tree. Okay. See, one thing I have already cleared, that the number of node that present in the tree and the number of node that present in the graph are equal. Okay. Now, if you are given any graph and if you are asked what is the number of twig in a tree, your answer will be n minus 1. if your graph contain 5 number, here the graph contain 4 number of nodes, so number of twig in your tree will be n minus 1, that is 4 minus 1 equal to 3. Okay. Now if you check, see how many twigs are present? 4, 5, 2, 3 twigs are present. Why? Because your graph contain 4 number of nodes, so your number of nodes, so n will be 4, so 4 minus 1 is equal to 3. Okay. See, this tree I have also drawn from this main graph. This graph contain 4 number of nodes. So how many twigs you are expecting for any given graph? Definitely 3. See, 5, 2 and 3. 3 number of twig you can see here also. Just like 4, 5, 3. 3 twig you can see here. Same thing you can see here. Okay. This is one tree, this is another tree of this given graph. Both this tree contain 3 twigs. Why? Because twigs always, number of twigs always equal to n minus 1, where n is the number of nodes that present in the given graph. Okay. So number of twig is equal to n minus 1. Okay. Now if I assume the number of link is equal to L, then how many number of link you can see here? 1, 2, 3. 3 links you can see here. So here number of link is equal to 3. Clear? Number of link is equal to 3, 1, 6 and 5. Number of twig also 3, that is n minus 1, 4 minus 1 is equal to 3. Number of twigs are 4, 3, 2. So total number of twig is also 3. Now if you see how many branch present in that given graph is the summation of link and twig. If you make a summation of total number of link and total number of twig, you will get the total number of branch in the given graph. So total number of branch in the given graph B is equal to twig plus link. Okay. Twig plus link. Okay. So B is equal to T plus L. Okay. I am writing this again here. So B is equal to T plus L. Okay. So T is equal to what? N minus 1 plus L, where n is the number of nodes present in the given graph. So L is equal to B minus n plus 1. This formula is very important. It sometimes comes in your Makaut exam or other university exam also. This relation is very important. This is the relation between link, number of branch and number of nodes. Clear? One more thing is, how many number of trees can be possible? Okay. See, this is your given graph. Okay. How many trees I have drawn? Only 2 trees, this one and this one. Okay. This solid portion is the part of the tree only. So this one and this one, these 2 trees I have already drawn. So how many trees are possible? Okay. See, for a complete graph, I have already discussed in my previous class what is complete graph. In case of complete graph, the number of trees is n to the power n minus 2. Okay. So for a complete graph, number of possible trees equal to n to the power n minus 2, where n is the number of nodes present in the given graph. How many number of nodes present here? 4. And if you see, this is a complete graph, because in between all node pair only one branch is present. Okay. In between any two node pair, if you see, only one branch is present. So this is a complete graph. So for a complete graph, this formula is applicable. For a complete graph, how many trees are possible? N to the power n minus 2, where n is the number of nodes. So how many nodes are present in that complete graph? 4. So how many trees are possible? 4 to the power 4 minus 2, that is equal to 16. Okay. So So 16 trees are possible, out of that only 2 I have drawn here. Okay. So 16 trees are possible. So this formula is only applicable for complete graph. What if this graph is a incomplete graph? For incomplete graph, the number of trees is something different, that I will discuss sometime, after some time I will discuss. For a for now, just remember, for a complete graph number of trees is 16. Okay. For incomplete graph, if you want to know for incomplete graph how many trees are possible, then first you have to know what is incidence matrix, then you have to know what is reduced incidence matrix. From there you can say how many number of trees can be possible for a incomplete graph. Okay. Okay. Now I am going to start with incidence matrix. Okay. Now for a complete graph, see I am taking here this graph. Okay. So this is a complete graph. What I told you, for a complete graph number of trees n to the power n minus 2, as this is a complete graph and 4 number of nodes are present, you can clearly see. So number of trees will be n to the power n minus 2, that is 4 to the power 4 minus 2 is equal to 16 trees are possible. Okay. So 16 trees are possible, out of which I have taken only a one single tree. Okay. Now how to draw incidence matrix? Okay. So before we are going to incidence matrix, you should know that the order of the incidence matrix is n cross b. The order of the incidence matrix is n cross b, where n is the number of nodes and b is the number of branch. The order of the incidence matrix, order of the incidence matrix is n cross b. You can clearly see I am drawing the incidence matrix from this graph. Okay. This is our given graph. I am drawing the incidence matrix from this graph only. So the order of the incidence matrix will be here. Number of node you can clearly see A, B, C, D. Number of node is 4, and number of branch you can clearly see 1, 2, 3, 4, 5, 6. 6 branches present. So it will be 4 cross 6. Now how to draw the incidence matrix? See, before drawing the incidence matrix, first you write all the nodes in that in column wise. Okay. Then you write all the branches. 6 branches are present. Okay. Now see this graph. See this graph. If you consider node A, okay, see this graph. If you consider node A, how many branches are going outside, going outward from this node? You can clearly see node 1 and node 5 are going outward, and node 4 is incoming, sorry, branch 4 is incoming to node A. Branch 1 and branch 5 are going outward, and branch 4 is incoming to node A. So if a branch is outgoing from any node, you will take it as 1. If any branch is incoming to a particular node, you will take it as -1, and if any branch is not at all associated with any node, then you have to take it as 0. Now see, I am considering node 1. You can clearly see branch 1 and branch 5 are outgoing. So if you consider node A, branch 1 is outgoing, so I am taking it as 1. Branch 5 is outgoing, I am taking it as 1. Branch 4 is incoming to node A, so I will take it as -1. Rest of the branch is not associated with node A, so I will take it as 0. Okay. Now if you similarly consider node B, node 1 is incoming, sorry, branch 1 is incoming to node B. So branch 1 is incoming, it means it will be -1. Now see, branch 2 is outgoing from node B, so it will be 1. So it will be 1. Okay. Branch 6 is also outgoing, so it will be 1. rest of the branch is not associated, so I will take it as 0. Okay. Now consider node C. In node C you can see 2 and 5 is incoming, so 2 will be minus 1, 5 will be minus 1 and 3 is outgoing, so 3 will be plus 1. Okay. Rest branch are not associated with C, so I am taking it as 0. Now consider node D, the last node, you can see 4 is outgoing, so take it as 1, 4 is outgoing, 3 is incoming, so take it as minus 1 and 6 is also incoming, so I am taking 6 as minus 1. Okay. So rest you take as 0. Okay. One important property is, this is our incidence matrix. I have already constructed the incidence matrix. One important properties of incidence matrix, if you see, if you go through column wise, you can see the sum of all the column entries is equal to 0. If you check any column, if you check this column, the sum of the column entries minus 1 plus 1 0. Okay. 1 minus 1 0, 1 minus 1 0. So sum of all column entries for incidence matrix is equal to 0. Okay. Now this is our incidence matrix. Now what is reduced incidence matrix? Okay. See, the reduced incidence matrix is, if I remove the last row, if we remove this row from this matrix, it will become incidence matrix. So now your reduced incidence matrix is, if I remove this last row from this incidence matrix, so it will become your reduced incidence matrix. Okay. So what will be your reduced incidence matrix? There is no space actually in this board. So your reduced incidence matrix will be 1 minus 1 0, 0 1 minus 1, 0 0 1, minus 1, 0 0, 1 0 minus 1, 0 1 0. This portion will be your reduced incidence matrix. See, this portion will be your reduced incidence matrix. Okay. The order of the incidence matrix is 4 cross 6. Now what will be the order of reduced incidence matrix? Obviously 4 minus 1 cross 6 it will be, so 3 cross 6. So reduced incidence matrix, the order of the incidence matrix is n cross b, and the order of the reduced incidence matrix will be n minus 1 cross b. In general I am telling, here it is 4 cross 1, the order is order of the incidence matrix, and for reduced incidence matrix the order is 3 cross 6. In general the order of incidence matrix is n cross b, the order of reduced incidence matrix will be n minus 1 cross b. Okay, clear? So now I am considering this incidence matrix whose order is 4 cross 6 as A. Okay, I am assuming this is my incidence matrix, A is my incidence matrix. Okay. Okay, and this 3 cross 6, that is this reduced incidence matrix, I am assuming this as R of A. RA is suppose your reduced incidence matrix. Okay. So what I told you, for a complete graph the number of trees is n to the power n minus 2. As I am taking this as a complete graph, we already know 16 number of trees are possible, but for incomplete graph the number of trees is equal to, for incomplete graph for incomplete graph the number of trees, the number of possible trees equal to RA matrix into RA matrix transpose of RA matrix का determinant. Okay, determinant of RA and RA transpose. This will give you the number of trees in incomplete graph. See, this is our complete graph. So, we can clearly conclude the number of trees is n to the power n minus 2, that is 4 to the power 4 minus 2 is 16. But what will happen in case of incomplete graph? For incomplete graph, the number of trees is determinant of RA and RA transpose. Okay? One important thing is this n to the power n minus 2 formula, this n to the power n minus 2 formula is applicable for only complete graph. Okay? But this formula is applicable for complete as well as incomplete graph. See, for a incomplete graph you can put this formula, you will get the number of possible trees. But if it is a complete graph, you can also put this formula to get the number of trees. But this formula is only applicable for complete graph. Okay? So, this is our complete graph. Okay? From this formula we already know 16 number of possible trees are possible. Now, we will check it by this formula, because this formula is applicable for complete as well as incomplete graph. I will check this by this formula whether our answer is 16 or not. So, let us check. Okay. So, I have already constructed this reduced incidence matrix from this graph. Okay. You have already seen this, and this is the transpose of this reduced incidence matrix, and the number of possible trees for an incomplete as well as complete graph is the determinant of RA into RA transpose. We know this. Okay. So, this formula is applicable for incomplete as well as complete graph. So, as this is a complete graph, number of possible tree is 16. I am going to check it by doing RA transpose. Okay. So, this is the transpose of reduced incidence matrix of this given graph, and this is the reduced incidence matrix of this graph. Okay. Now, I am performing the matrix multiplication. So, it will be determinant of RA transpose equal to, see, this is the first row, this is the first column. If you multiply these two, you will get 1 into 1, minus 1 into minus 1, 1, and 1 into 1, 1. So, total 3. Okay. This is simple multiplication. All of you have did this in your 12th class. Okay. So, now next, this is the first row, I am considering the second column. It will be your minus 1. Okay. Now, first row, third column, it will be your if you check it, it will be your minus 1. Okay. Now, consider the second row with second row and the first column. So, minus 1 into 1, minus 1 plus minus 1 into 0 plus 0 into 0 plus 0 into minus 1 plus 0 into 0 plus 1 into minus 1 into 0. How much you will get? I think it will be your minus 1. Okay. Check it by yourself. Next, second row, second column. Okay. So, this will be, if you check it, it will be 3. Okay. Now, second row, third column. Okay, check it. Second row, third column, it will be -1 again. Okay. Now third row, first column, it will be -1. Third row, second column, it will be again -1. Third row, third column, it will be your again 3. Okay. So, I have performed the matrix multiplication. Okay. Do it with yourself. Okay. Practice it. Then what is the determinant of this? If I find the determinant of this will be 3 -1 -1 -1 3 -1 -1 3. Okay. This position are odd position. You already know odd position is associated with -1. So, what is the determinant? 3. If I consider 3, remove this, you will get 3 -1 -1 3. 3 -1 -1 3. Okay. Now consider -1. As this is the odd position, so minus into -1, that is +1. So, remove this column, second column, first row. When you are considering -1, remove second column and first row, you will get -1 -1 -1 3, -1 -1 -1 3. Okay. Now consider this -1. If you consider this -1, remove third column and first row, you will get -1 3 -1 -1. Okay. How much it is? See, this is -1, sorry, this is your -1, 3 into -1 -3, -1 -1 +1, so this will be -1, so this is -4, so your answer will be 16. This 16 I am expecting, you are also expecting this, so I am getting 16. So your answer is okay, because if you put n to the power n minus 2, again you will get 4 to the power 4 minus 2 is equal to 16. Okay. This formula is only applicable to find the number of trees in your complete graph. Okay. In your complete graph, number of trees can be found by the formula n to the power n minus 2. But as this formula is applicable for incomplete as well as complete graph, and as this is your complete graph, I have applied this formula, I am getting 16. So, this is the same answer I am getting. So, by this formula you can calculate the number of trees in complete as well as incomplete graph. Okay. So, what we have covered today? We have covered today subgraph, twig, link, and tree, co-tree, twig, link, and incidence matrix. And in my next lecture I will cover tie set matrix and cut set matrix. Okay. So, I am ending this lecture with that. Okay. That's it. Thank you.